It is determined where most of the meteorites that they hit the Earth. Every day in the Earth's atmosphere there is hundreds of tons of material from its space. Mostly they are tiny crumbs that do not even reach the surface of the planet. From time to time, there is a larger rock that is capable to cause serious damage. In a recent study, astronomers have established the origin of 90% of the meteorites that hit Earth by linking them with collisions that have occurred in the relatively recent past. Until recently, only a small fraction of the meteorites that hit on Earth, scientists have been linked to their mother bodies. Some of these cosmic rocks come from the Moon and Mars, but the source is most asteroids. In a new study, astronomers have determined that 70% of all the known meteorites come from only 3 asteroid families that formed in the main asteroid belt as a result of 3 relatively recent collisions before 5.8, 7.5, and about 40 million years. Researchers also identified sources space rocks, which together allowed to identify origin of over 99% of all known meteorites that have hit our planet. Results and description of the research appeared in 3 publications on Nature and Astronomy and Astrophysics. Meteorites are rocks of extraterrestrial origin that have arrived to the surface of the Earth. But when they are still in space, they are called meteoroids, if they are small, and asteroids or asteroids when they are large. Clear streaks crossing the night sky, also referred to as falling stars, is from meteor railroads, traces left in the atmosphere after passing meteoroids, once part of larger objects. These remains fall into Earth atmosphere at a huge speed of several dozen kilometers per second. In the contact with the atmosphere is violent evaporating, leaving behind its a visible trace. Astronomers are distinguished 3 types of meteorites: stone meteorites, iron meteorites, and meteorites the iron cast. Stone meteorites consist mainly of silicates, iron, magnesium, and are found in 2 types. They're chondrites and achondrites. The most common are chondrites. They make up 85% of all meteorite found on Earth. Most of them are known as chondrites. It's ordinary. Among several other types are also chondrite coal, which contain a lot of carbon and water. Researchers believe that it is not they have undergone greater transformation since the beginning of the solar system, and they contain the dust that originally formed our planetary system. The 2 types of stone meteorites are achondrites. Their composition it resembles a basalt. Unlike chondrites, they have been treated high temperatures and melted. Meteorites are divided into 2 broad categories: chondrites, which are almost impenetrable fragments of the early solar system, and achondrites that come from different bodies, i.e. planets or asteroids, from layers of the nuclei, mantle and shell, the authors of one of the publications explained. A group of researchers in publications also explained that of more than 70,000 known meteorites, so far only about 6% have been unequivocally identified as coming from the Moon, Mars, or Westy, one of the largest objects in the asteroid belt. These are achondrites. Origin of the others 94% remained in the field of speculation. Behind the research is an international team of scientists led by researchers from CNRS, French National Center for Research, European Southern Observatory, ESO, and Charles University in the Czech Republic. In their own, the researchers used a combination of detailed telescopic observations and computer simulations to compare asteroids in space with meteorites found on the Earth. This allowed the type of rock and paths to fit the orbital one. As a result, a team of researchers showed that 70% of all the known meteorites come from 3 young asteroid families: Charon, Coronis, and Massalia. They were formed as a result of collisions in the asteroid belt, which is located between the orbits of Mars and Jupiter, about 5.8, 7.5 and 40 million years ago. Most meteorites that fell to Earth, as much as 37%, came from a family Massalia. These young families stand out from all the facilities asteroid belt: extremely large abundance of small fragments left after the collisions. This abundance increases the risk of collision between them, and in combination with their high mobility, their escape from the asteroid belt. Families created in the result of older collisions does not have so many smaller pieces and are depleted the sources of meteorites. Smaller fragments that they once consisted of, they eventually disappeared after decades of subsequent collisions and theirs. Of dynamic evolution. Asteroid belt itself is made up of millions of objects collected by Jupiter's gravitational interactions. Interactions with gas the giant can impair the asteroid orbits and cause their collisions. In this way a cosmic debris is created, which over time begins to live its own life. From modeling shows that the Coronis and Massalia families provide the right one the sizes of objects and are located in a position that leads to drooping material on the Earth. While Charon, Coronis, and Massalia are the source most meteorites, a team of researchers found that bigger, dangerous objects have their origin elsewhere. In the case of NEO, near-Earth objects close to the Earth, about the size of a kilometer, our model he points out that most of them come from only 2 families, Polana and Euphrosyne. On the other hand, a stream of Carbonian chondrites with a metro size it is dominated by only one family, Veritas, the researchers pointed out. Examination of these asteroid families will help us determine between others, what is the probability that the Earth will be hit by them. For example, collisions of asteroids that have occurred recently may constitute more threat, causing more collisions and chaos that could allow fragments escape from the waste and direct them to a collision course with the Earth. Although going from just 6% of meteorites whose origin has succeeded to trace, to more than 90%, is an impressive step forward, this about 10% remain unidentified. The team plans to continue its research, focusing on young asteroid families that formed less than 50 million years ago.